So welcome to this last video of KVL. This is the part 2. We've gotten to our determinants and Cramer's rule stage. So we want to calculate for delta, delta 1, delta 2 and delta 3. So, and we know how to do that. We slot here this 1 by 3 matrix here to get delta 1. We slot this 1 by 3 matrix here to get delta 2. Then we slot it here to get delta 3. So our I will be this, the current flowing here. Our IN will be the current flowing. You see the same current flowing here. That will be the one we are using delta 2 to calculate. Then our VL here, since we already know the I that is coming here, we will now multiply it by the voltage will be IR, right? So multiply the I multiply by that 6. That will give us that. So we have I here, we have IL and you have VL. So I think we are good to go. Let's calculate for our determinant. Now for this, we have determinant is equals to 7 into brackets 11 multiplied by 11, that should be 121, then minus this times this, that's 60, then minus, we have plus minus plus, so minus and minus, this one will be plus 5 into brackets this multiplied by this, that should be minus 55, minus this multiplied by this is 0, so 0, this one is making it plus. Then for 0 you have plus 0. You see, anything you multiply 0 it will be 0, so I don't think we have to do anything here, so just put 0. Then we come here, let's calculate 121 minus 16, that is 105 times 7, that will be 735 plus, this is minus 55 already, multiplied by 5, minus 55 multiplied by 5, that's minus 275, minus 275. We don't have anything here, so let us solve what that will give us. This is 460, this is 460 for the theta. So delta 1, I want to draw determinant for delta 1. So what would that be? We are bringing this one here, so we have minus 25, 0 and 0. Then you pick this one and this one, slot it there, and in their normal state. So let us solve for delta 1. Delta 1 will be what? Delta 1, so minus 25 into brackets this multiplied by this, that's 121, minus this multiplied by this 16. It's still the same thing that we, okay, no, it's not really the same thing. So this minus is here, remember, plus minus plus, minus times minus will give you plus 5 into brackets 0 multiplied by 11 will be 0, minus this multiplied by this, that one is also 0. So then for this part 2, then once the 0 is multiplying, I don't think there's anything you want to do there. Everything will be 0. Everything will be 0. So for this we have, let's calculate 121 minus 16 and multiply by minus 25. We have minus 2625. Are they following? So let us calculate. This is already amounting to 0 already. 0 multiplied by 5, then is 0 here too. So let's do for delta 2 and see what we have. We draw our determinants for delta 2. Now we are slotting this one at the second row. We have minus 25, 0, 0. Then put this one here, this row, 7 minus 5, 0. Then put this one here, 0 minus 4. So we are picking from our new determinant, we are mixing it with the results. So what we have here, delta 2 will be 7 into bracket, this is 0 minus 0, that's gone. Then remember, there's always minus here, so it will be plus 25 into bracket this multiplied by this, that will be minus 55, minus this multiplied by this, that's 0. Then 0 here again is multiplying whatever is here to use 0, because that one is just waste of time. But in case you are doing it in exam, make sure you do it in detail so that you can see your workings. So this one is 0 already because it's multiplying 0. Then plus, let's solve this, minus 55 multiplied by 25, that is 1 minus 1375. Let's go for the last one. I hope this place can contain. Okay, so we are now picking into the last place here for the delta 3, 0, 0. Then we pick these two normally. We have 7 minus 5, 0. Then we have minus 5, 11, then minus 4. So for delta 3, we are going to be having 7 multiplied by, this is 0 here, because 11 multiplied by 0 is 0, minus 0 multiplied by 0 is minus 4, that also is 0, because minus and minus, you can just put plus to indicate your sum. Then remember, minus is always here in the middle, so that will be plus 5, open bracket. Then this one is 0, minus 5 times 0 is 0, then 0 times 0 is also 0. So the last part, there's always plus here, plus times minus is minus, minus 25 into brackets. We are using this multiplied by this is 20 and minus 0. So the answer is minus 25 and 0, minus 25 times 20. So let's see that times 20, that's 500, minus 500. So we can see now. Okay, where can I clean so that we can solve for our data, our voltage and current that we are asked to look for. Let me draw our I here, which is going to be our normal I. Our I1 is equals to I. The I that we're looking for is our I1. So, and that will be delta 1 over delta. So what's delta 1? Delta 1 is minus 2625 over our data is 460. Let's calculate that. 265 divided by 460. So that's 5.0 minus 5.70 ampere. Then for the second part, IL will be, since this one is for here, I2 will be for this, then IL will be here. Remember, this is the first I1, this I2, this will be I3. So since we need IL, we don't need to solve for I2. So let's just go straight to IL. So when we get IL, we now use that IL to multiply the resistance to get our VL. So that's it. So IL, I3 like that will be is equals to IL. Then it is equals to delta 3 over delta, what's delta 3? Minus 500 over 460. So 500 divided by 460 will give us 1.08. That will be minus 1.08 ampere. So for the last one, VL. What will be our VL? Since V is equals to IR, so VL will be IL multiplied by R, you can say RL, and it's still R3. So you can multiply it like that. Since our RL is minus 1.08, multiply it by 6. That will give us our voltage. So 1.08. Approximately this should be 1.09. Approximately. I didn't approximate, so it should be 1.09. 1.09 multiplied by 6. So that's 6.5 6.52 volts. 6.52 volts. So that is the end of this applied electricity for the Kirchhoff voltage law. So we are going to be doing other things also when time comes. Thank you. Let us like, share, subscribe, and also broadcast to everywhere. Thank you very much.